Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is Bhavik Vyas. Bhavik is the Director of Technology Sales and Partnerships at Aspera Company. Welcome, Bhavik.
Hi. Hi, Rich. How are you?
Oh, terrific. Just coming back from a big trip to Germany and looking forward to hearing your slides today. Do you want to go through those?
Absolutely. Okay, so thanks for the opportunity to introduce Aspera. Very quickly, we're a software company. We've been around for 7 years, and our speciality is WAN optimization specifically for big data. So we deal, in slide 2 of my presentation, we deal specifically with the problem of moving very large digital assets. And those can be computer modeling or seismic data or music, audio, video, genomic sequences, satellite images. And the type of companies that use Aspera today are ones that are creating or transforming or trying to monetize this type of data. And so their whole business is predicated in the creation and the distribution and ultimately the movement of this data as part of their business process. And so Aspera's unique value is delivering software solutions that help these companies optimize the movement of this data as part of their business requirements. And so some of our customers require very quick movement of this data because it's very time sensitive. And the size of the data and the time-sensitive nature of the data means that efficient movement of that data becomes the primary requirement. And so the next slide here shows just what does Aspera mean by big data? It's becoming a very big phrase in like cloud computing is in the marketplace. For Aspera, big data really refers to actually just the sheer size and volume of that data set. So for our media and entertainment customers, for example, they're dealing with data sizes that are in the hundreds of megabytes, tens of gigabytes, hundreds of gigabytes, and sometimes thousands of gigabytes in size. So if you can imagine a 3D movie file, when it's in its sort of uncompressed, editing-based format, it's a tremendously large file. And so moving that file over a potentially a global sort of collaboration workspace becomes a very challenging part of the movie creation. And sometimes for our customers, the data size is either a single object or it could be a few objects, or it could actually, what we're showing in the top left here is that it could also be hundreds or even hundreds and thousands of smaller files. But the problem is still the same in the fact that this entire data set needs to move from A to B. And so you may wonder why data has to move. So slide 4 here is showing how the solutions that we're enabling for our customers are really sort of mission critical, but involve a lot of WAN transfer. So specifically in the application or in the industries that our customers work in, so media and entertainment, life sciences, software distribution, selling, cloud computing even, and even HPC, there's a lot of WAN transfer driven by the fact that a lot of what people do is business to business. They're doing global collaboration and sharing. They have a need to build ingest systems. So these are systems that are capable of collecting large volumes of data on a daily basis, or conversely serve up that data for people to download on a daily basis. We enable transformation solutions. So HPC is an emerging one in the media and entertainment world. It's all about rendering and transcoding and encoding. And so that requires high capacity storage at very high speeds, delivered to pretty much anyone on a national or a metro, national, or even international basis. Cloud services is an emerging area for us, especially as we look to infrastructure as a service. So that's the ability for a Microsoft Azure and Amazon Web Services to spin up 1,000 compute nodes in a matter of minutes for you to crunch your job and then turn them all off again. But access to that infrastructure is key. And so as we go down, and then also an emerging market for Aspera and also for our customers who are struggling to deal with this data is the ability to actually manage it from a business perspective. So DR, synchronization, migration, continuity, all those things become key. But it's not now based just on, an Oracle database or mission-critical CRM. It's all around this highly sensitive and constantly created data. So the next slide, we try to put this into context, which is just, often for people that are new to Aspera, the need to move data is sort of an unknown part of the business workflow. But what we see our customers doing is really, truly international global collaboration and the need for access to data pretty much from anywhere, from anyone at any time. And in business to business, where you might have different partners for a project basis or for a scheduled basis, or you might outsource based on need, you don't know where that person or that group or that skill set is going to be. And as the data gets larger and you need more specialist people, you often just have to physically have to replicate the data. And what Aspera is doing is focused on a digital way of doing that through web browser technology or through client technology and server technology. And so the next slide shows just how Aspera does what it does. So we're doing WAN optimization for big data, all in software. And we do this because our customers are predominantly doing transfers over public internet circuits, sometimes private, but it's always to end users or to end applications or end systems. And so traditional WAN optimization focuses in on optimizing the point-to-point link, where you have to buy hardware and you have to own both ends. Our users need flexibility, and they have a very dynamic workflow, which means that what Aspera does when we enable WAN optimization for big data, we're saying, well, irrespective of how far you have to travel or how much bandwidth you have, Aspera's job is to maximize the bandwidth so that you can move your data quickly. And we do that by having a specialized protocol and a software client-server software application that pretty much runs on every common operating system that you can think of. So Windows, Mac, Linux, Solarix. We have a very unique partnership with Isilon Systems, which is now part of EMC, where we run natively on high-performance storage. We also work on Amazon Web Services. We're working with Microsoft Azure to port our product to that platform. We then run in every common web browser, and we also run on the iOS and the Android. So basically what we're enabling is an anywhere-to-anywhere movement of data per the business requirement and workflow that you have, not based on what physical hardware you have necessarily or what network connection you have. So this versatility becomes very key to our customers. And the next slide shows really what, from the purchasing perspective, what the problem is. The one side of this these two people on a seesaw here is really we're trying to solve the time versus money problem, which is if I have a short amount of time in which to get my data to someone or back from a system that might be transforming it, how much money am I willing to spend? Now that's going to be driven by the business requirements. So when you then go down to what are you going to buy, you're going to invest in WAN products and WAN bandwidth and high-performance storage systems, and you're going to invest in security controls and the HPC CPU infrastructure that might do that transformation or analyze the data or whatever the application is. And on the other side, you're going to say, well, how quickly do people need to access this? Do I need to enable anywhere collaboration? Do I need to have all my users close to these assets, or can I have them anywhere and just build it in a very cheap data center? And let's say in the middle of Nevada, where power is cheap and space is cheap. So Aspera is really helping to balance this cost and access. We enable access by enabling people to use their bandwidth over any distance, which allows people to build systems and infrastructure and workflow to actually move the data as part of their business requirement. So you might now say, well, that's all great, but what's the issue that people have today? They've got FTP, they've got secure copy, and HTTP. So what we see in our market, and why Aspera is very successful in doing what we do, is that as data gets bigger and as bandwidth becomes more available, it's actually more and more difficult for customers to use that bandwidth for actually the efficiency they're looking for. So So what I have, the little graphic here, is basically a roadblock. There are roadblocks in actually trying to use cheap bandwidth and trying to use cloud-based services or central high-performance compute clusters by remote people because of the fact that they can't get their data in and out quickly sometimes. And so the next slide here just shows a very simple example of just what happens to bandwidth and then what happens to the application that you use over that bandwidth. So my slide 9 here, shows a very simple scenario. If I have an office in Seattle and an office in Paris, and I'm able to purchase a WAN connection in between, so I purchase 1 gigabit connection, 1,000 megabits per second. And my service provider gives me a very nice fixed latency, 170 milliseconds, and I get an okay packet loss rate. 1 packet out of every 1,000 is lost. You could get better packet loss rate, definitely. This also could be public internet if you had the access to this bandwidth. So I have 1 gigabit per second of bandwidth, but if I use an application like FTP, which is built on the TCP protocol, based on this network characteristic, my actual throughput is only 29, let's say 30 megabits per second. And so what's happening here is that we're losing 997 megabits of this 1,000 megabit per second connection that I'm paying for based on just how well TCP works in this environment. It's nothing to do with the bandwidth at this stage. It's all to do with the protocol. And so to put it into context for our customers, at this speed, 30 megabits per second, a 50 gig file would take 4 hours and a 1 terabyte file would take 3.3 days. And that 3.3 days is where the business decision is made. Do I invest in the bandwidth and do I build a workflow that is capable of using the bandwidth, or do I need to move my data on disk using FedEx or UPS? And so that's the type of decision customers have had to make in the past. And it's all based on the protocol. So in the next slide, what we show here is that the TCP, in the way that it's designed, and in today's big data, high bandwidth, global collaborative work sort of environment, it's not well suited to the bandwidth that's available. And so TCP powers all of these protocols: FTP, Secure Copy, rsync, HTTP, CIFS, NFS, all standard, well-used, highly deployed protocols and applications used for moving data. But when efficiency becomes key, what we find and what our customers are challenged with is that as distance increases, this graph is really here to show that irrespective of the bandwidth that you have, the further you have to send your data, the lower the transfer rate will be. And the more packet loss in the system, the worse the transfer rate will be. And it's all based on an equation, the way TCP works. Now, there's lots of tricks you can do with TCP, but you have to be skilled in doing those. What our customers find is that their business is predicated on partnering with multiple people or selling to multiple people. And so not everyone can be experts jointly in configuring TCP to work well. So commercial solutions do provide a very useful way of bridging this gap. And ultimately, as much tinkering as you can do with TCP, you're never going to get the 1,000 megabits or the 10,000 or the 1 gigabit or the 2 gigabit or the 10 gigabit WAN transfer from New York to Sydney, for example. That's going to be very, very, very difficult. And so Aspera, what we do is we have a patented software protocol that is designed to eliminate this. So the next slide shows pretty much the same graph in the fact that TCP is affected by this latency and packet loss condition in the WAN. Aspera designed a protocol and an application to basically eliminate these problems. So it focuses on the core problem of TCP, and instead of trying to optimize it, we decided to say, well, let's just design something specifically to solve this problem, rather than trying to improve upon something that fundamentally just wasn't designed for what it now needs to do in certain applications. So we have this protocol called fasp, and it basically is an application protocol that is designed to eliminate the effects of latency and packet loss for WAN transfers, which means that we give our customers 100%, if they wish, 100% bandwidth utilization over any distance, over any type of IP network. We give them high efficiency in terms of the ability to use that bandwidth. It's all the data it's fully reliable. We have full data integrity. We do full CRCs. More importantly, on top of that, we also provide full security. So we do encryption, especially over public networks, that's key. We do secure user authentication. We then have bandwidth control policies and logging and auditing, and we provide a whole infrastructure on top of which people can move their data. But the core thing that we're solving here is the efficiency part. When people need to move stuff fast and they have the bandwidth, then Aspera becomes a very compelling solution. So if I move to the next slide, and we look at the same scenario that I described, Seattle and Paris, I have my 1 gigabit connection with the same service provider. Before, I could only go at around 30 megabits per second with a single TCP transfer, so one FTP stream would go just this fast. With one one Aspera transfer, assuming I can use all of this bandwidth, Aspera gives me, if I invest in Aspera, it gives me the ability to actually use this bandwidth. So now with an Aspera transfer, I can go close to line rate across this wide area network. So a single transfer will go at around 995 megabits per second versus the 30 megabits per second with TCP. And that's a gain of 34 times. Which means really, you can look at it two ways. Firstly, it saves me a lot of time in moving data, but also it's allowing me to invest in this bandwidth and actually use it. So the cost of bandwidth that's unused is a hidden cost in the enterprise and any workflow or any business. But if I can use what I pay for, it becomes doubly efficient. If I bring it back to the time scenario, the FTP transfer versus the Aspera transfer, my 50 gig file, which took 4 hours, will now take 7 minutes with Aspera, and my 1 terabyte file, which took 3.3 days before, will now take 2.4 hours. And 2.4 hours in a workflow is acceptable, very acceptable versus 3.3 days. It really changes the way you can build and architect systems for the future. There's global access, anywhere access. Put my data where it's cheapest, put my compute where it's cheapest, but just give me access to it. Bandwidth is going to get cheaper and cheaper, and more of it's going to be available. So it's really how do we utilize that with the right technology set. And so that's what Aspera does for our customers. And we have over 1,000 customers today using Aspera in this way. Not everyone has a 1 gigabit connection, but some of our customers do. A lot of them have over 100 gigabit. We also go up to 10 gigabits per second. So we're really able to scale to meet the infrastructure capacity and nothing else. And so the next slide really shows, what this value proposition from Aspera is very interesting, because as the bandwidth grows, we give our customers the ability to use the bandwidth. And so this eliminates, we're not now concerned about how far it has to go, or really what the conditions of the network are. This could be wireless, it could be satellite, it could be microwave, it could be fiber optic or cable or internet IP or private or a VPN tunnel. It makes no difference. As long as the bandwidth is there, we can use it. And as our customers invest in bandwidth, so as their business grows, the Aspera software will scale to meet that bandwidth that they have, and their transfer times will go down. So it's a linear equation, basically. File size divided by bandwidth is how long it will take to send with Aspera, the back of the envelope calculation. And so that becomes very compelling for our customers. And so the next slide really just shows that we're building sort of we enable a solution frame. We have a solution framework that really enables customers to embed this into their workflow. We support this whole range. We have the core protocol in the middle, this fasp protocol, and it is able to be deployed on a multitude of operating systems. Pretty much anything with the TCP IP stack we can use, but it's really, we're looking at platforms here, Windows, Linux, Mac. There's so many different types of interactions between different OSs ultimately, and we can run on all of them, which means we can then build out this framework of big data access. So we have the protocol, we support multiple OSs, we offer security around all of the data transferred. We then allow people to embed our protocol. We have an API, we have a mobile client, we have a client-server model in terms of integration, so we can be sort of embedded or exposed or hidden, depending on the use case. We then have full monitoring and reporting and bandwidth control. And then on top of that, we offer automation tools. So now we're really building in a workflow, because people don't just move data. They move data to then do something else with it, and the something else is what we do next. And so if I move away from that to my final few slides here, what our customers then do with their data becomes very interesting. So now we fixed the problem of moving it quickly. And now the next question is, well, what do you then do with it? And so this slide here shows what our media and entertainment customers may do. But if you're in the HPC world, once you get the data, you're probably, there's a whole heap of other things. You may run Hadoop, you may run MapReduce, you may be doing data analytics, you may be doing image analysis. There's thousands of applications that run, but they're all automated. Moving the data is one component of a much bigger system. And so Aspera also offers the ability to then begin to programmatically engineer the workflow such that it becomes fully automated. Ultimately, the end user goal is really, here's my data, analyze it and give me the result. All the intricacies in between are really not that concerning to the end user. They have to interface with them, but really you want to just automate the entire thing. So some of the things we do for our customers is we do DMZ forwarding, especially when you're using public IP and you've got private infrastructure in the back. We then can trigger workflow, so we can, in the media world, for example, we work with partners that provide video quality or transcoding and encoding and watermarking and then distribution, maybe to cloud-based services or CDNs. But we can build an automated workflow such that as soon as data comes in, provided you know what you want to do, you can fully automate the entire sequence. It might be, for example, once I have this data from this customer, I can spin up 1,000 cores to analyze that data. Once the data is analyzed, I may want to return them back a result or store it in a certain location or do something else to it. And we can begin to automate a lot of those things or be part of that automation process. And the final slide just sort of shows, this is a little bit media focused here, but it sort of shows the inputs with respect to sort of the workflow and the fact that we can do virus scanning or FTP transfers or we can do uploads and downloads, but fully automated. Because when data is received or moved in volume, there are many things associated with that, from antivirus scanning to metadata checking through to delivery notification and integration into ERP, CRM systems and things like that. So this type of automation becomes key, and it's really building upon our product set. And so with that, Rich, I sort of reached the end of my presentation. Hopefully it's been a useful introduction into the problem, the challenges, and one of the solutions where Aspera's sort of core protocol is used and deployed in terms of solving bandwidth problems and efficiency.
Well, thank you for that, Bhavik. A couple questions here. So if you can tell me what's going on under the hood with the Aspera software, are you using UDP or something like that and putting some kind of layer on top of it, or what's going on?
No, so you've hit the nail on the head. So we when people mention or talk about UDP, there's a lot of raised eyebrows, and it can be pretty scary for a lot of people, especially based on sort of BitTorrent and things like that work well, but can often be overwhelming from a network perspective if they're not controlled well. So Aspera's protocol, the fasp protocol specifically, and that's this slide 11. Is designed to make FASP itself is a reliable protocol built on UDP. So UDP has no reliability, which means you can send it as fast as you can, and actually you can overwhelm a network by sending too much of it. So the trick is to understand how much to send, how fast, and then to build reliability and data integrity and security on top of it. And that's what the FASP protocol does. So we have to rely. Pretty much every OS has the TCP IP stack, and TCP. Its sister is UDP. It's just a different header on the same layer. But we build on top of that. We leverage that component, and then we build this reliability, bandwidth control, efficiency, security, data integrity on top. And with the type of data that we move for our customers, data integrity is crucial. We've all experienced the 99% upload or download where the last 1% fails or is corrupted and you have to start again. That isn't acceptable in the world that Aspera is used in. And for these mission critical big data type of movements, you can't have that risk occur in your system. And so CRCs down to the packet level becomes crucial, and that's what this protocol is designed to do.
So, I mean, just from my experience, trying to download big files with TCP, and then coming across BitTorrent, and I suddenly see my network is capable of 20x or 30x more. It's just really astounding. Is that the kind of speed up that customers might expect with Aspera?
Yeah, so we're very cautious to not give you a number. It's primarily, and I'll be very open why, because ultimately we don't. The performance of Aspera is going to be purely based on how much bandwidth you have, and because we're not, with the type of data we move, we can't cache it, we can't compress it. There's no optimization you can do at the data at the ones and zero level. You basically run the file, and so our the end user's performance with Aspera will be purely based on how much bandwidth they have available for transferring a file, and then secondly, how much they wish to use. But for people with, let's say you have a cable, if you have cable modem providing you internet access, generally now it's sort of 20 down, 10 up, or something like that, for short bursts, and Aspera is able to maximize that. And sometimes with FTP and HTTP, you do get good throughput, especially if you're close to the server you're connecting to, where the latency is low and the packet loss is low. But as you get further away, your ability, it becomes more challenging. And so Aspera really eliminates that distance packet loss problem. So the gains can be anywhere from 2 or 3 to several hundred, primarily driven by the network condition and where the user is in location to the server. But essentially, we're capable of using all of the bandwidth that we're given, and then from there, then we can determine what the ultimate gain is.
So, Bhavik, we've seen this just dramatic growth in unstructured data. Does this software offer any advantages for that kind of situation?
But so the unstructured data, if we look at that second slide that I presented, I mean it's pretty much made up of all of this. It's unique files or unique directories that are created on a massive scale, and that unstructured nature of it means that optimizing it becomes much more difficult. And so yes, so unstructured data is pretty much this. It's it's PDFs, music, video, image files, just everything that we deal with actually as end users quite often. We're not. It's ironic actually. The end user probably creates more unstructured data than than what we would see from the enterprise system perspective, which is very regimented and table orientated, like a database. But we create, when we take movie files and images and download music and want to watch content, it's all unstructured data. And so yes, Aspera plays it's a very key, it's a key aspect of what we do. But it's really that we're focused on the size and the complexity of that unstructured data and moving it as part of a business need or an end or a prosumer need or sometimes even a consumer need.
So I guess one wrap-up question here, Bhavik. You guys have been in business 7 years. How has the problem changed that you're trying to address for your customers?
That's a fantastic question. So I have to credit the Aspera co-founders. They saw this problem and solved it 7 years ago before it became a major problem for the amount of customers that we now have. So what we're seeing is that we called it bulk data before, and then big data was coined probably in the last 2 years, along with cloud computing. But what we're seeing is the market is moved. The market in general is this problem is being forced into the market because the type of data is changing and the volume of it is unprecedented and will continue to be. And so, while we solved this problem 7 years ago, if we look back 7 years, DSL was the common way of accessing the internet. Everything was based around maybe 1 or 2 megabytes of bandwidth. There was no iPhone. There was no high-def camera in your mobile devices. So there's just nothing around to create this volume of data. Now we're here in 2011. We're starting to see service providers talk about gigabit to the home. Bandwidth is ultra cheap. You've got things like Amazon Web Services, which power an incredible amount of applications that we see and offer this new vision for high performance compute, both private and public. So the bandwidth is here, the data is here, and so what we see is that our media and entertainment were the first adopters because they moved to digital, but we're now seeing that genomic sequencing, medical imaging. The industry is having to address this problem of efficiency and also deal with the nature of just the volume of data is going to be unprecedented as we look forward. And so, very exciting for Aspera. And what's really fantastic to be able to say to our new customers is we're not launching a new product. We've got what we build upon now is mature, and highly deployed. So it's very refined, and it's great to be able to say this is what it does, and these are all the people that use it, and so it's an emerging. the whole world is sort of emerging into this problem, and so it's a very exciting time. But the more bandwidth that is available, the more value there is in sort of solutions like Aspera, and actually being able to use that for a positive purpose.
Hey, Bhavik, I want to thank you for coming on the show today. This is very interesting. It looks like the sky's the limit for Aspera.
Hey, well, thank you very much for the opportunity. It's definitely very exciting, and we're very excited to expose people to what we do. It's not for everyone, admittedly, but this becomes highly valuable to this big data market, and it's great to be able to tell the story.
Well, terrific. Okay, well, thanks once again. That's it for the Rich Report, folks. Stay tuned for more news and information on high-performance computing.